Now, from software design perspective, the main idea behind this trust zone is to create kind of isolation between the user-based application and the firmware that we trust. The user-based application, this is something that get updated often, and this is something coming from the user. Therefore, we cannot trust those applications. Hence, we cannot give access to sensitive informations and hardware blocks to those user-based applications. Those ones are quite vulnerable and they can damage our hardware. Besides damaging our hardware, they can actually steal and leak sensitive informations out of our secrets, like some cryptographics, secret keys, and so on. So we need to block the access to those sensitive informations by those user-based applications. Hence, we will use this trust zone concept to isolate this user-based application that we don't trust from those sensitive and secret informations. And this is what we are calling the non-secure state. So the non-secure state is the state of our Cortex-M 33 CPU while executing this user-based application. And while running in non-secure state, then we'll have certain restrictions and limitations at CPU level to access certain sensitive areas and informations. Now, on the other hand, for the firmware and the software that we do trust and is allowed to access those sensitive and secret informations as well as sensitive hardware areas, this one will be isolated in secure state. Means those trusted firmwares will be executed while the Cortex-M 33 CPU is running in secure state. And this secure state will give the CPU privilege to access those protected areas. You can see it as two independent projects and softwares. Each one is running in separate state, and each one will have its own access permissions and context of execution. Finally, at a certain moment, our non-secure application or this user-based application may require certain services from our trusted and secure firmware. Hence, we may need to communicate via certain function calls to our secure firmware. So the user-based application will initiate certain requests and function calls to our trusted firmware. This one, in return, will process those requests and then give back basically the result via certain callbacks to our user-based application. So this is the flow, as you can see. Set of function calls coming from the user application, and then we'll have certain callbacks as a result coming out of our trusted firmware to the user-based application. And during boot, our device will boot by default into secure state. So the Cortex-M33 CPU, after power on reset, will be executed in secure state. And there we can embed a secure boot functionalities and firmware to set up basically our hardware blocks. After we finalize the secure boot, we need to initiate the first jump to our user-based application. This one as well has its own predefined flow to guarantee that there is no sensitive informations are leaking out of our trusted firmware when we do the first jump to this user-based application. So what we need to keep in mind is that with this trust zone, we'll create isolation between the user application and the firmware that we will trust. The user application will run in non-secure state. The firmware or trusted one will run in secure state. And ARM has set up set of predefined flows to communicate back and forth between the non-secure and secure state.